Good morning, everyone. So before we start, I would like to actually just go through one of the questions that I set for you yesterday. Some of you told me that this was a hard one, so let's just take a look at it because it probably looks harder than it actually is. So, first thing we're asked here is to sketch this graph. A very important word here is sketch. It's not asking us to properly graph the function. So it doesn't have to be up to scale. You only need to show a few features of your function. So for example, in your graph, since you're sketching, you should show your asymptotes, right? Those have to be expressed if they exist. If you don't have any asymptotes, well, you just don't have them, so you don't show them. Another thing is any intercepts. Usually the intercepts, they are shown. So y-intercepts, x-intercepts. So whenever you're crossing either the x or the y-axis, you should label those. So usually those are the information, right? This is the information that you need in order to sketch a graph in an acceptable way for the IB. So if we try and investigate how this graph would look like, we would need to analyze, because this is not a function which is easy to graph if we don't observe how it's going at infinity, right? So if I just ask you, okay, graph this function, it's going to be tough. However, if you take those limits, and I know that the second part of the question is asking us about limits, but we're going to do them now. Why? Because they're going to help us understanding and figuring out how this graph, how this sketch would look like. So for instance, if we take the limit of this function, e to the power of x, e here is a constant, alright? Now this constant is actually called Euler's number. You don't have to memorize this, but it's basically it's a sum. It's a sum of a series, right? But we usually approximate this to 2.71828. Okay, I know some decimal places usually don't have to use that much, but this is a good approximation. You should have this e in your calculator, right? And there is also an inverse function when you have, for example, y equals e to the power of x. If you take the natural logarithm on both sides, you would have that x is the natural logarithm of y. Just like if you had y equals a to the power of x, then to get rid of the exponent here, you would have to do log base a of y equals x. Okay, natural log, if you don't remember, is basically log base e. Okay. Anyway, so if we take this limit, what's going to happen to e to the power of x? What happens to anything with an exponent? And if we increase this exponent, well, it depends if the exponent is positive or negative. If x is positive, in fact, if x is, let's say that x is larger than 1, okay, so we have square, cube, or even 1.1, 1.2, what's going to happen here is that this will grow and grow and grow indefinitely, so it's going to diverge. Right, if we keep summing up, it's going to grow, grow, and grow. Now, if this exponent is negative, if we increase and increase and increase, we're actually doing 1 over e to the power of x. So we're getting to a smaller and smaller and smaller number if x is less than 0. Right? So if it's negative, so it's going to converge. I'm not going to discuss now what's in between. But what only matters here to us is, okay, if we go really far to the positive side, to the negative side, it's going to converge, because it turns into 1 over something that's growing. So it's becoming closer and closer to 0. So when we take this limit, this will be 0. So this is going to be just -6. This is constant, so it's always the same. So it's something that's getting closer and closer to 0, -6. So it's -6, because if you get as close to 0 as you can, that you can neglect it, it's -6. So this is one of your asymptotes. So this means that when you go far to the left in your graph here, you will have some asymptotes, and this asymptote is y equals -6. Now, as we discussed before, when you grow your exponent and it's positive, what's going to happen? It's going to explode. It's going to grow and never actually reaches a value. So what's going to happen with this function is something like this, right? And here it's going to diverge. So there's no asymptote on this part of the graph, only on the negative, only on the left side. Now there are still features that we have to find. We need to find the intercepts. So how do we find the intercepts? Well, in this point here, x is 0. And in this point, y is 0. So if I take x equals 0, what will be f of 0? Well, that's e to the power 0 minus 6. Anything to the power 0 is 1. So that's 1 minus 6, which is -5. So this point here, our y-intercept is -5. Now how do we find our x-intercept? Y is going to be 0. Okay, so y equals 0, which is equal to e to the power of x minus 6. So if we rearrange this, we should get e to the power of x equals 6. Now to get rid of this, we will have to use our logs, natural logs. So if we take the log on both sides, I will write down as many steps as I can so you understand what's being done. So I'm taking the natural logarithm on both sides, and I should still have equal things. There's no reason to expect otherwise. Now when I take natural log of e to the power of x, the base of natural log, this is log base e to the power of x. So this is x. Okay? So x is natural log of 6. And yeah, unless you put this in your calculator, that's what you're gonna have. And usually they don't ask you to put this in numbers, because this is going to be a number. It's not going to be a very nice, beautiful, like integer. It's going to be a very awful number. It's not going to be rational. So just leave it like log of 6, so you have the exact value and not some rounding problem. Okay, so we check, so we have sketched our function. This would be our sketch, and that's fair enough. It's good enough. Okay, we've put our asymptote, we've put our intercepts, and now let's look for letter B. Discuss the value and geometric interpretation of those two limits. So the first one here is the limit when we're going to negative infinity. Well, and we have found that was -6, and that's expected. And this means it's an asymptote. That's the geometric interpretation. Now the second one, it diverges. right? It's not going to get close to any value, any specific value. So it's nothing. It's not an asymptote. It doesn't exist. This limit does not exist. Basically, what does it mean for a limit not to exist? Well, you may approach this function to this value, right? And you will never actually reach some value. You can always go further, in this case to infinity, and you will have a larger value, a different value. So it doesn't actually get to any specific number, and that's why it diverges. So the limit does not exist.